It's crazy about here in the US about how much resources that we do use. So it's said that highly developed countries, which are about a fifth of the world's population, account for over half. Now think about that. 20% of the population is taking 50% of energy and materials, and we generate about three-fourths, 75% of all pollution and waste products. So, what can we do? Well, we could look to see the type of resources that we're using. We could look at renewable versus non renewable. Now, I know you've heard about these for many, many years. Non renewable, such as fossil fuels, um, renewable, such we could talk about solar energy, a couple other different types, get into ethanol, that type of thing. There's none that are perfect, but we'll talk about a few different types. We could practice what's called green chemistry. Green chemistry, or you're using chemical practices, and this can apply to your everyday life also, that aim to conserve resources and reduce generation of waste and toxic substances. So you're going to reduce what you use, you reuse, so maybe you use a reusable bag instead of using just a plastic Walmart bag. And then you recycle what you can. So for um, aluminum cans, you put them in the recycle bin. So reduce, reuse, recycle. Reduce, reuse, recycle. That's the part of green chemistry. There's more to that whole thing, but this is the starting point. So we want to have less byproducts. We can also look at reducing our energy use. So one of the conferences I went to was talking about green chemistry and how you could do heat up a substance in labs. So what's the best way if I need to heat up a solution? Is it better to get a Bunsen burner, a hot plate, or stick it in the microwave, which would have less of an environmental impact? Little things even like that can make a huge difference. So as we're looking to see this is looking at an item's full environmental impact. This is called a life cycle assessment. Life cycle assessment. This can get pretty interesting. So we're going to see everything from the raw materials, what it takes to extract or to get those raw materials, turn the raw materials into a product, transport that product, how are you going to ship that product to the user, how much of an environmental impact the user has, and then what do you do with it afterwards? Do you recycle it? Do you throw it away? What's that going to do? So everything from raw material all the way to end of life. Sometimes they'll talk about from cradle to grave. Um, okay, couple of examples. Laundry detergent. Laundry detergent today is said to be more concentrated, so it's better for everyone. That just means they've removed some of the filler. Well, that does have some important concepts with it. You use smaller packaging. It takes less energy to transport it because it's smaller packages now because we've removed some of the filler, the stuff you really don't need to have. So, yeah, slightly less environmental impact. Here's another example. If you go to the grocery store, what type of bag should you use? Paper or plastic? Or should you use a cotton bag, like a canvas bag? Well, these life cycle assessments can sometimes get a little tricky. So, if we look at the first part, the raw materials, the manufacture, the assembly, getting it to places, the thing with the smallest, what they call a carbon footprint, is actually that plastic bag. It's much easier on the environment to make a plastic bag, even using fossil fuels, than it is to make a brown paper bag or that cotton canvas bag, because you could look to see how much cotton does it take and the amount of land, the amount of water. These can get very, very detailed. But what happens when you're done with the bag? Now, ideally, that brown paper bag, that cotton bag, they can decompose. But what about that plastic bag? It has a much harder time actually breaking down. There are places, especially on the West Coast, that are now banning plastic bags just for that reason. So we have to look at the entire life cycle to be able to figure out, well, there's going to be some personal weighting of some of the different issues. We're really concerned about having those plastic bags that can't decompose. So we're going to try to eliminate those and rather go to something else, even though it has more of an environmental impact to make. Here's another example. So you go to the grocery store and you need to buy some meat. How should that meat be packaged? So back when I was young, you could go and you'd have meat packaged in like butcher paper. Butcher paper is just a really heavy paper. Sometimes it would have like a waxy feel to it. And then it went to having it wrapped in plastic plus the butcher paper over the top. And you can still get stuff processed that way, especially if you are butchering your own meat or having it processed for you. Um, but if you go to the store, you'll notice that most things are in styrofoam containers. But isn't styrofoam bad for the environment? But it's very, very popular to wrap meat in. Well, if you look at environmental impact, the butcher paper would have less of an impact for the packaging. But what about what's inside? Why do we use styrofoam to put your chicken breast or your beef or whatever in, to store it in, to transport it back to your house? Well, that styrofoam is an insulator. And so what they have found, they've done a lot of studies on this. What they have found is that you have less meat spoilage if you put it in the styrofoam. Okay, so now if you add that into this whole equation, what makes the most sense? Well, that is for you to figure out. Our next little survey question. We get much of our energy through petroleum materials. Petroleum is a renewable resource. Now this particular question has two parts. The first one, we get much of our energy through petroleum materials. That is correct. We can take that raw material, we can separate it based on the boiling points, and then we can use each of those fractions for many, many, many different components, including our gasoline, our diesel fuels, paraffin waxes, and all sorts of stuff. The second part says petroleum is a renewable resource. That's the tricky part. Petroleum is a non-renewable, meaning that we can't easily regenerate it. So where did petroleum come from? Well, in class I always kid with the students and talk about how it came from the dinosaurs. There's more to it than just that, but a really simple answer is something to that effect. Petroleum is not renewable. We are still producing petroleum in nature. It's just occurring at a much slower rate than what we're using it. So this particular question would be false. Each of the following are a concept of green chemistry except reducing waste, not making products, using renewable resources, or recycling. So green chemistry has three parts to it. A lot of times as people are talking about being green, we talk about reduce, reuse, and recycle. So we need to reduce the waste that's produced as we're making a product. We are going to reduce the use of fossil fuels. We can recycle to be able to reuse some of the products that we have. But the not making products is not technically in the green chemistry cycle that we talked about. Even though that would probably have one of the bigger effects, just don't require that things be made, it's not actually included. So on this one, not making products would be the one that you're looking for.